Are emergency light phones keeping you safe on campus? By Taryn Traylor,
Rachel Faldyn.
Cameron Stelly, and Jakob Vitullo.
Texas A&M University is home to 145 blue light emergency phones that are dispersed across campus, outside building entrances, and in parking garages. An emergency can take place at any time and anywhere on a university campus, which is why universities across the globe have made the safety of their students a top priority. Emergency blue light telephones located across our campus are provided to ensure a sense of safety for our students. Today we are going to present the results of our project analyzing the distribution of the emergency blue light telephones located across the Texas A&M University campus. We will discuss the relationship between what areas of campus have a visible view of these emergency phones in real life versus the actual geographic locations of them. To determine this, we proposed the research question: are the emergency blue light phones on the campus of Texas A&M University geographically distributed to ensure the maximum safety of its students? We hypothesize that the emergency blue light phones are in fact distributed spatially in order to maximize their efficiency.
For the methods portion of our research, the first thing we decided to do was to contact the university to find out if emergency light phones had already been plotted using a GPS unit. We started the investigation and ended up getting information from Mr. Chris Mathis, who is the GIS coordinator for the Office of Facilities Coordination. He provided us with geographic locations of emergency phones that had already been taken. Once we had this information, we were able to narrow our research to really capitalize on the emergency light phones in the areas in question. To begin this process, we narrowed the area of study to just campus in between Wellborn Road, George Bush Drive, University Drive, and Bazell Street. There were several reasons why we did this. First, this area is where the majority of students live on campus, so this project would contribute to their safety during activities or even just moving from place to place. We also narrowed the area to use the boundaries to our advantage and to maximize our group's ability to collect accurate points in familiar areas. For collecting points in our methods, we divided these areas of campus into quarters and collected waypoints on sidewalks where an emergency light phone was not visible. 2 of us collected points during the day and 2 of us collected points during the evening. We were then able to combine these waypoints using ArcGIS so that we could observe the relationships between areas of campus with visible views of phones in real life versus what the geographic locations show on the map. ArcGIS will bring spatial results to the project by combining all of these elements into one real-life visual element. And just some facts about the data. As a team, we collected approximately 570 waypoints using the Garmin GPS unit. As for the settings on the GPS, we used NAD83 and we also had WAS enabled to have that accuracy and precision already incorporated into our points. UTM coordinates were then recorded when a waypoint was taken. And I included a chart here just showing some examples of a few points that were taken. It's kind of interesting to look at.
We are now going to look at the general findings from our results. In our study of the main or eastern section of the university's campus, we found that the total area was comprised of 1,732,760 square meters. However, our study focused on traversable space, specifically designated sidewalks. The area studied contained 23 emergency phones and 529,122 square meters of sidewalk. Of this 529,122 square meters, 102,415 square meters were found to be obstructed. These obstructions range from trees to permanent buildings to changes in the elevation of the physical landscape. In addition to permanent obstructions, some areas contained construction sites which served as temporary obstructions. Regarding the spatial distribution, in analyzing our study, we found that the average density of the emergency phones were 1 for every 75,337 square meters of the total study area. Looking specifically at sidewalks, we found that for about every 23,000 square meters, there existed 1 emergency phone. However, 19.36% of the sidewalks were obstructed. This value was determined from the total sidewalk area and not the number of sidewalk segments. Our data showed that there was not a strong correlation between emergency phone proximity and visibility. Despite being extremely close to some emergency phone sites, various obstructions barred them from visibility in nearly any direction. However, our data did show that areas one would assume to be highly trafficked, such as Academic Plaza, showed a broad extent of visibility. Our study did raise some areas of concern. Overall, as we assessed the effectiveness of the emergency phone system, we found some areas that gave cause for concern. Many of the obstructed sidewalks occurred near the perimeter of buildings and within corridors between buildings. This is potentially problematic given that perimeters of buildings may be highly trafficked and secluded corridors may show elevated risk for crimes taking place. Additionally, our study was segmented into 4 survey regions, and the eastern and western quadrants amounted to 68,620 square meters of obstructed sidewalks. This constituted 2/3 of all the obstructed sidewalks for our study.
Does the results from our data collection support our hypothesis? Our hypothesis being emergency blue light phones are distributed spatially in order to maximize efficiency. First, we must define what efficiency is and how it can be calculated with our results. 2 factors are to be noted for determining whether or not the spatial distribution is efficient. 1, the area of which a blue light phone can be seen from the ground, and 2, the area where 1 or more phones can be seen. In order for the spatial distribution to be efficient, the locations of the phones must maximize the visual range of blue light phones while simultaneously minimizing areas where the visual range of phones overlaps. With a spatial analysis of our results, we have concluded that our data supports our hypothesis. The individual locations of blue light phones covers large areas of which are highly frequented on a daily basis. The areas where blue light phones cannot be viewed are relatively smaller, and it can be inferred that they are relatively less frequented. Finally, there are only 2 locations on campus where 1 or more phone can be seen. Therefore, the area of visual overlap is minimal. How do our conclusions fit into the broader context of blue light emergency phones and the role they play on our campus? We focused on finding the efficiency of the spatial distribution of phones, but is efficiency alone enough to determine whether or not the phones are effective? By effective, we mean do the current locations and numbers of blue light phones accomplish their mission? The mission being the blue light phones being a resource that enables students on campus to get help when faced with an emergency situation. We have concluded that with the current distribution of phones that the efficiency of their placement is high, but there are still places where phones cannot be seen or accessed. Therefore, it is necessary for more phones to be built in order to make our campus a safer place.
What can be done in the future to expand on this research? Obviously, there is much more campus to study on the emergency light phones, and by doing so, this would service the university in making it safer. Collecting waypoints over the entire campus is definitely something that can be done to extend this research. Another thing that can be done is to bring in someone who's really good at observing data. They may be able to tell specific patterns in the points about what strategies should be used to make the campus logistically safer. And lastly, finding data on which parts of campus are the most trafficky during the day versus the night could be useful in the future studies on this research as well. We hope that our work will add on to these previous GPS studies of emergency light telephones in order to continue servicing Texas A&M University and making us and all students and faculty safer.